Okay, so say I want to graph this parabola, and I want to graph it by writing it in standard form. So standard form is what we were graphing before when we were moving stuff along the graph when we were moving a basic parabola. So it's something where you have f of x equaling a parenthesis squared and probably a number on the outside of it. So it looks like what we were doing before. We were shifting things to the left and to the right. In your book, it's going to be minus h plus k. But as long as you can get it to be what we had before, we were just using transformations, and that's going to be in standard form. So to write in standard form, we want to write it as a parenthesis squared, which means I want to complete the square. So hopefully you remember how to complete square. Otherwise, there are videos under the college algebra section about it. But we're going to go ahead and do it again here. And we're going to complete the square all on one side, which is going to be a little bit different than the videos in college algebra. But I'm going to rewrite it, start off by rewriting it like this. And I'm going to see if I can write just this part, that x squared minus 8x, and I left a blank there, as a perfect square. So writing it as a perfect square would mean writing it into, factoring into two parentheses that I can then write as that parentheses squared. So they'd have to be the same parentheses. So if I look at this, right now I can't. To factor this into two parentheses, I would need a third term here. Because right now, all I could do with this is pull out an x. So I would need a third term here, and usually when we're factoring, we're looking for things that multiply that third term and add to that second term. And usually when we're factoring, we say the first term of our factors, if it's x squared, it's just going to be x and x. So that part kind of works, because that part is the same. Don't forget, I need these parentheses to be the exact same so I can write it as a perfect square. Okay, so multiplying to a blank space doesn't really help me. But if I'm adding to 8, what is the only same number that adds to 8? It'd be 4. 4 and 4 would add to 8. And that'd be true for really anything. If you take half of it, the same number that adds to 10 would be 5. The same number that adds to 20 would be 10. The same number that adds to 21 would be half of 21, so 10.5. Or 21 over 2. So it's always going to be half of it. So I'm going to have 4 and 4, and since I'm adding to a minus 8, I'm going to do minus 4 and minus 4. Now this, again, isn't factorable to this yet. I need something in that blank space. So what do minus 4 and minus 4 multiply to? They multiply to a plus 16. Okay, so this looks good. This is factorable to x minus 4 whole thing squared. But I can't just add a 16. If I add a 16, I'm completely changing my equation, my problem. So in order to add nothing, because I don't want to change anything, so I want to add nothing, I also need to subtract 16. If I add 16 and subtract 16, then I'm basically adding nothing. Okay, so this factor to x minus 4 whole thing squared, and then minus 17, because minus 1 minus 16. So now let's see if I can graph this. Again, we have what a regular parabola looks like. So this would look like a regular parabola, but it would be moved to the right 4 and down 17. So I would go 1, 2, 3, 4, down to negative 17, draw my dot, and then try to recreate my parabola. Okay.